Okay, so we are going to learn the parent functions. The first function, let us take it to be very simple. That is linear function.
Yes.
Linear function. And you know that in linear function, we can write y is equal to mx plus c. This is the linear function. So basically, y means what? Fx. So fx is equal to mx plus c. And here you know that m is called the gradient or slope
Mhm.
of this function, and c is called intercept. Which
Yes.
intercept? Can you tell me? C is x intercept or y
The
intercept?
y-intercept.
It is y intercept. That means when you put x is equal to 0, this y will be c. That that one will be the y intercept. Okay.
Hmm.
For every parent function, we will see what is the domain, what is range,
Hmm.
and if any other information if it is required. So, like
Yes.
basically increasing or decreasing. So, can you tell me what is the domain for this linear function?
It'll be negative infinity to infinity.
Negative infinity to infinity. That means all real numbers.
Yes.
Perfect. And what is the range?
It is also negative infinity to infinity.
So, basically, again, all real number.
Yes.
Okay. Then, uh, what is the nature of this? Whether it is increasing function or decreasing function?
This is an increasing function.
How you will say that this is increasing function?
So because the slope is positive, it's increasing.
That here comes this slope is positive, but slope may be negative also, right?
Yes, but if the slope is negative, it'll be like it'll look opposite.
Decreasing. Yes. So you have to say that it is increasing function if
Mm-hmm.
okay. So we can write it is increasing if slope is positive. It is
Mm-hmm.
decreasing if m is less than 0. That is negative.
Yes.
Okay. What about when m is equal to 0? What will happen when m is equal to 0?
Then it'll just be like just the y-intercept because there'll be like no slope.
So in that case, this will not become a linear function. This will become a
Yes.
constant function. Just a
Yes.
constant function. Okay.
Mm-hmm.
Good. Okay. For this function, what is the y-intercept? As you have told, it is y-intercept is c.
Yes.
What is the x-intercept?
The x-intercept, that's not like on the actual thing. You need to like
No.
solve for the x-intercept, right?
So for x-intercept, you have to put y is equal to 0.
Yes. So you have to solve.
So how much you are getting? X-intercept?
So what's the slope right now?
Slope is
So if y equals 0, then you'd get like what?
x is equal to minus c by m.
Mhm.
So x-intercept is minus c by m. Y-intercept is y-intercept is c, right?
Yes.
Okay. So fine. This is what we should know about linear function. Now, one question that you
Yes.
can try. Okay. Shall I erase this one?
One moment, I'm writing it down.
Mhm.
Um, 1 second, I'm almost done. All right, I got it.
Okay. Now do this question. Question is write mm, write a linear function. Write a linear function for which f1 is equal to 3 and f4 equals 0. So draw it, means write the equation first and then draw the graph. So graphing is not that much tough. You first find out the linear equation.
All right, one moment.
Yes.
All right, the answer I got was y equals negative 1x plus 4.
Y is equal to negative x plus 4. Yes, that is 100% correct answer. Tell me what you have done.
So basically, first I solved for the slope. So you have 2 points right now. You have point 1 comma 3 and you have the point 4 comma 0. I just did the formula y squared minus y1 over x squared minus x1. That'll give you
Mhm.
something like negative 3 over 3, which gives you
Yes.
negative 1. So then you have y equals negative 1x plus b, or that's same as c. And then I plugged in one of the points to find c, so I did 0 equals negative 1 comma 4, or in parentheses 4, plus a b. You get 0 equals negative 4 plus b, and then b would have to be 4 for,
Yes.
yeah.
Yes. Perfect. Perfect. Good. Now let's move to the another parent function, that is square function. So
Yes.
our next parent function is square function.
Mm-hmm.
So if you look into the square function, uh, so see, we know that fx is equal to, we can say simply, let us take first very simple square function. Fx is equal to x squared. Okay. What do you know about this function? What can you tell about domain, range, whether it is even function or odd function, whether like what are the different intercept, whether it is increasing or decreasing. So increasing or decreasing. Yeah, can you tell me? Just look at it and
So
tell me.
so the domain is negative infinity to infinity, so it's all real numbers still. And then the range is now uh 0 to infinity.
Okay. So it is minus infinity to infinity, and the range is 0 to infinity. Perfect. Because
Yeah.
it cannot be negative.
Yes.
Whether it can be 0, so if it is 0, so we have to write down inclusive bracket here. Inclusive.
Yes.
Then whether it is even function or odd function.
What do you mean by even or odd?
Perfect. See, what do we mean by even or odd? So if we have any function, if we put if we put x as minus x, then if f minus x is equal to fx, we will say that this is even function. Whereas if f minus x is equal to minus fx, then that is odd function. And if you can't determine this, then it will be neither even nor odd.
Oh, so you do like if negative x is equal to positive x,
No,
so
no,
wouldn't
no,
this be
no, no,
even
no,
then?
no. Not negative x is equal to positive x. F, when you substitute x as minus x, if you are getting the same function, for example, here it is even function. Why? Because when you put x as negative x, you are getting f minus x as x square only.
Mm-hmm.
So this is one even function. This is even
Yes.
function. But if you look into the cubic function, cubic, fx is equal to x cube. Here, if you put minus x, you will get minus x cube.
Mm-hmm.
So cubic fx is equal to x cube is odd function, but fx is equal to x square is an even function, because
Yes.
when you substitute x as negative x, you will get f minus x is equal to fx.
Mm-hmm. Okay.
Okay. Then what are the
So then,
intercepts?
so the x-intercept is 0.
It is passing through 0 0, right?
Yes. And then it's all, yeah, 0 0 for the intercept. And then increasing, it's like from 0 to infinity, it's increasing.
Yes. And
And then
decreasing?
decreasing, it's from negative infinity to 0.
Perfect. Very good. Can you draw the graph for this?
Yes. It'll look
So y is
something
equal to
like
x squared.
you'll have oh,
Hmm.
that's your like thing, and then it'll look something like this.
So is there any symmetry here?
Yes, there's symmetry on like it'll be like this.
Symmetry about y-axis. Correct.
Yes.
It is symmetry about y-axis, and it has a minimum value here. It has a minima. This is y is equal to x square. Correct.
Yes.
Okay. Now let us look into other kind of other parent functions. So this is done. Remember, all these parent functions are very very important. So
Mm-hmm.
now we will look into the other one. So let us check. Next parent function is cubic function.
Mm-hmm.
So let us check very simple one. Fx is equal to x cube. So tell me, what is the domain? Just think of it. What is range? Whether it is even or odd. If it is y, then what are the intercept? Then whether it is increasing or decreasing. So increasing or decreasing, in which interval it is increasing or decreasing, you can write. Is there any symmetry or not? If it is, what is this symmetry, or what is the nature of the symmetry? So yeah, tell me one by one.
So first it's the domain is from negative infinity to infinity.
Yes, range.
Range is also from negative infinity to infinity.
Yes, I think this you can take help of your Baron's book. There also it is given. You can just look at it and just Explain it, no problem. Okay.
The even or odd. So it's odd because like if you run like a line through it, then it'll like there won't be like any symmetry.
Yeah, you remember we have already done it, that graphing of polynomial function.
Yeah.
And since it is odd degree, so we know that this we can write like this one, is it not?
Yes. There's no symmetry, so it's odd. The y-intercept is 0, 0.
Huh?
Or not the
Increasing,
y-intercept, the
decreasing.
intercept. So it's increasing from 0 to infinity, and then it's decreasing from negative infinity. Oh no,
No, it is
it's
always
increasing the whole
increasing.
time. It's always increasing. So
It is
from
always
negative infinity
increasing.
to infinity, it's increasing.
It is,
And then
it is
it's
not. Here we
and
have
then it's
seen, yes, you see, here we have seen arrow, but in reality, we have to always start with the left hand side.
yes.
Okay, so every time you can see, if you draw the slope, slope is always positive. So that
Yes.
means it is always increasing. Very good. And is there any symmetry?
Yeah, no, no, there's no symmetry. Or
No,
no, there is.
there is a
It's
symmetry.
along the x-axis,
No, not along the x-axis.
correct?
No, no. See,
Then,
a symmetry means if you are saying along the x-axis, that means if you put one mirror here, whether you can see this? No.
hmm
If you put mirror here, can you see this one? No.
no.
So that means mirror cannot be put there. But
Yes.
if you look into the point O, this one, if you look into this point, about this point you see whatever is happening here, it is just happening here. So it is, yeah, it is symmetric, but with respect to origin. Just a
Okay.
point, about one point. It is not about the line. Remember, cubic
Yes.
function, this function is symmetric, not about any line. It is about a point, which is the origin.
hmm
Okay,
All right.
good.
So it
Because
has origin. So you say it has origin symmetry?
yes, it is. It is symmetric about the origin.
hmm
Okay, good. This is the cubic function. So note it down.
Yes.
Then we will see the other parent functions.
Yes. 1 second, I'm writing it down.
Okay, done.
Almost 1 moment. All right, I finished.
Yes. So, right. Now we will see another parent function,
hmm
square root function.
Okay.
So now this is the square root. So basically what happened that fx is equal to root x.
Yes.
This is the square root function. Okay. Uh, but here remember that we have to fix up the domain
hmm
because as a whole, if you draw this graph, just fx is equal to root x. If you plot it, can you tell me what is the approximate graph you are getting?
Um, so like on the calculator, or should I look at the book?
You can use the calculator GDC and tell me
Okay.
what is the graph that you are getting.
I got it looks something like this.
Yes. So here you see why the calculator is giving this one, because actually if you plot it, you will get this. You should get this. Why? Because if you take x is
Mhm.
equal to 4, y is equal to plus minus 2. But the problem is,
Yes.
if you draw this particular graph, it will not represent a function, because function always pass the vertical line test. That is the
Yes.
reason that we will start, and your calculator has also given you the graph starting from here.
Mhm.
Okay, that defines our domain. So what will be domain? So domain will be all the, yeah, can you tell me what is the domain?
So domain is 1 second. It's 0 to infinity.
Yeah, it is 0 to infinity. So whether 0 included?
Yes, it's included.
Perfect. And what will be range?
Range will be 0 to infinity. Or is there like a
Yes.
aspect?
Yeah, we will take 0 to infinity. Here important is
Mhm.
we will not take the negative values of fx.
Yes.
Otherwise, this will not become a function.
Yes.
Okay. So that's why we will take range as all the non-negative real numbers.
Hmm.
So domain and range both will be non-negative real numbers.
Hmm.
Okay. Now coming to the okay. So tell me what is the intercept?
The intercept is 0, 0.
0 0. And increasing or decreasing?
It is increasing.
It is increasing for all its interval. Perfect.
Yes.
This is what we have to do. Okay, please note it down. Then we will look into the
So
another function.
this one will not have what's it called again?
Symmetry or this thing, right?
Yes, it does not have symmetry.
No,
Yes.
no,
It
it
doesn't
is
have.
no symmetry. Correct.
All right.
It has no symmetry.
Mm-hmm. One moment.
And it is neither odd nor even. That we cannot say, because we cannot take negative number. There is no meaning of it.
Mm-hmm.
So we have already taken domain as all the positive real number. Then there is no point in including the negative x here. So
Mm-hmm.
no even, no odd. Okay, neither even
Yes. What?
nor odd.
1 second.
Neither even nor odd. Okay.
1 moment. All right, I finished.
Okay. Now we will look into next parent function, that is reciprocal function.
Mm-hmm.
So reciprocal function. As you know, the reciprocal function means we will write fx is equal to 1 over x. Okay.
Yes.
Now just think of it. Domain. What you can do, you can just from the graphic calculator, you can draw the graph first.
All right.
Okay. Based on that graph, you tell me what is the domain, what is the range, whether it is even or odd or neither.
Mm-hmm.
Find out the intercepts, if any, whether it is increasing or decreasing, increasing and decreasing, and about the symmetry. So first you plot the graph.
Yes. So the graph looks something like this. So the domain is it's it's negative infinity to infinity, right? Or is there like a hole here?
There is a hole here.
So what
It
would you put? Like
can,
negative infinity to 0 and then 0 to, so it'd be like negative
yes,
infinity, 0, and then 0 to,
yes, yes, because x cannot be 0. So we have to
mhm,
avoid that one. Now, what will be
yes.
range?
The range will be negative infinity to 0 and then 0 to infinity.
Yes, same thing. So 0 to infinity. Very good. Then whether it is odd or even or neither.
It's odd.
Because if you put x as negative x, you will get, so f minus x is negative 1 by x, that is minus fx. So it is
Yeah.
odd function.
Mhm.
Okay, intercepts?
So is there an intercept because it
No,
does
no,
not touch
no.
0, 0, right?
No,
Or
no. Not about 0, 0. It does not touch x-axis, it does not touch y-axis. So there
so there's
is
no intercept, right?
no intercept at all. Okay, now increasing or decreasing, tell me.
One moment.
Mhm. Always look from the left hand side.
So this function is it'll be like decreasing, right?
Yes, it is
From
always decreasing. Always.
yeah,
From, see, minus infinity to infinity, if you draw the slope, how we will understand? You just draw one slope and see that what
yeah.
is happening. If you draw slope,
So
it is making obtuse angle. Here also you can draw slope, it is making obtuse angle. So everywhere
yes.
slope is making negative. So it is not increasing everywhere, it is decreasing everywhere.
hmm
Decreasing everywhere except at x is equal to 0 where it is not defined.
Yes.
Okay, what about symmetry? Whether there is any symmetry?
There's symmetry along the
Not along.
x-axis
No, no,
or
not x-axis.
is it
You,
y-axis?
no. See, understand this thing. If it is symmetry about x-axis, graph should
hmm
look like this. If it
Oh,
is if it is symmetric about y-axis, graph should look like this. But
so like
graph, huh,
so what kind of symmetry would this be then?
about the origin.
Oh, this is also origin symmetry?
Yes, yes. So
Okay.
about the origin. So we have seen two function which is symmetric about the origin. Which are those
Mhm.
two function?
It's reciprocal functions and cubic functions.
Perfect. And whether we have seen any function which is symmetric about x-axis till
No.
now? Whether we have seen any function which is symmetric about y-axis?
Yes.
Which one?
It was the quadratic function.
Correct. Whether we have seen any function which is not symmetric at all?
Yes, the square root
One more
function.
function. Linear.
Oh
Linear
yeah, and
function.
linear function.
Perfect.
hmm
So this much is given in your textbook, Baron's book, but we can do one more parent function that is called
hmm
step or piecewise function that we will do. Okay. First you
Yes.
note it down. First you note it down, then we will see the piecewise function.
I've written it down.
Okay. Now let us look into this one. Okay. So next, our parent function is step and piecewise function.
hmm
Piecewise functions. So basically, step function means it will look like this. Graph will look like this. So what is that
Yes.
step function? The most famous of the step function is greatest integer function.
hmm
Greatest integer function. This is one of the famous step function. Its symbol is fx is equal to, we write down like this one. Okay. So basically, it's not the bracket. So to avoid the bracket, we normally write down two uh, two such brackets combined.
hmm
Okay. So this is greatest integer function, and it is defined as fx is equal to x. This is defined as the greatest integer greatest integer less than or equal to x. Let us see some example for this. Then only we can write down the domain and everything. So if I give you that what is f minus 1, that is what is the greatest integer function for this minus 1. So you see minus 1 means we have to find out one integer which is less than or equal to x. So which is that integer which is less than or equal to minus 1? Answer will be minus 1. Is it not?
Yes.
But if I ask you this one, what is the greatest integer function of minus 1 half?
What do you
So
mean?
means which integer is less than or equal to minus half?
Oh, okay. It'll be what? Um,
Minus 1
less
only.
than, less than? Yeah, less. Minus one also is less than minus one half. Yes.
Okay. So if I give you 2, so what will be answer?
It'll
It will
be
it will be 2
one.
only.
Or
No,
oh,
it
it
will
can
be
be
2.
equal to it.
Yes, it can be equal to.
Oh, okay.
But if I give you 1.5, so what will be answer?
It'll be
The
so
1.
less than or equal to, so one.
Perfect. This is the greatest integer function.
Mhm.
Okay. Now, based on this, first you write it down, then we will write down the domain and range for this thing.
Yes.
You can expect questions from this step function.
Why do you do two brackets?
This is just symbol. In many books,
Okay.
in many books you can get once just one bracket only. So it is okay, fine. It will be mentioned in the question that it is the step
Okay.
function or it is the greatest integer function. That will be always
Yes.
mentioned. But maybe you will not get that one and just bracket will be there. Then in that case you have to understand that this is greatest integer function.
Mm-hmm.
So let us, okay, first you write down this, then we will see the properties of this step function.
Okay. I've written it down.
So now this is our step function. What do you think? What will be domain? So there is no restriction, right? Anything you can write. So minus infinity
Yes.
to infinity. What is range?
So the range, it will also be minus infinity to infinity, right?
No, it will be, but it can be any. It can be only integer.
Okay.
Whereas
But why can't it?
it can be any real number.
Oh, yes, I understand.
Yeah, but it can be only the integer, and that is positive and negative, both integer, it is valid. So we cannot write minus infinity to infinity, although its range can be minus infinity to infinity. We will
Yes.
write set of, we will write its range is set of all integers.
Yes.
Okay. Then tell me the intercepts. What do you think? What are the intercepts? And interestingly, you have in your GDC, you can write down this graph also. You can try.
What do you
So
mean? Like, what is GDC?
Your calculator, that is called
Uh,
GDC.
so the so what is
GDC
the
means your calculator is known as GDC, graphic display calculator.
so how would you like so you're saying you can graph this on the calculator?
Yes, you can do it.
How?
Okay, okay, we will do that. First, let us write down this intercept.
So
So
would the intercept
mhm,
not be 0, 0 because they're integers?
yeah, it will be 0 0 because if you
Yes.
put 0, your answer will be 0. So one intercept is 0, 0, right? So, okay.
Yes.
And there will be another intercept. Another
Um,
intercept will be,
would it mean like
uh,
1/2 0 or like
no, no, no. It intercept will be x and y. You can see its intercept will be 1. If you put 0 to 1, whatever you will take, you will get 0. So 0 to 1. This
yes,
is again another intercept.
yes.
So intercept means it is we have intercepts, x intercepts in this interval. Remember, we have x intercepts in this interval.
Yes.
Then this graph always jumps vertically 1 unit at each integer value. That is very, very important. So let me write here this. So we will draw the graph also. So this graph jumps vertically,
Mm-hmm.
vertically 1 unit at
Mm-hmm.
each integer value. What does it mean? It means that if you look into this, see, its graph will be okay. First you write down this, then we will draw the graph. We just write down this one, then we will draw the graph.
Yes, I've written it down.
Okay. Now let us draw the graph. So graph is this one. Okay, x-axis. This is negative x-axis. Okay, y-x. Now, if you look into this, any point, so let it be 1, 2, 3, 4. Any point between 0 to 1, you see, any point between 0 to 1 will give this answer 0.
Yes.
Any point, so this is 1, 2, 3, 4. Any point between 1 to 2, 1 to 2
Yes.
x. So we will draw here this one. So any point between 1 to 2, not including 2. So we will get this one as the answer. Any point between all the values of x between 2 to 3,
Mm-hmm.
2 to 3 will give you the value of 2.
Yes.
Okay? So that means you can see that if we are jumping 1 unit ahead, you see
Yes.
this one. Okay. So this is the step function. So here also it will continue. Here also it will
So,
continue. Hmm?
so it'll just continue infinitely?
Yeah, it will go up to infinity, but only the integer value we will get. Why we are getting only integer value? X can take any values, but y will take only integer values.
Yes.
Okay. Now, this is step function. Now, one last parent function is left, that is piecewise defined function. And already we have already covered exponential and log function previously. So we are not going to cover this here.
Mm-hmm.
Okay. So now let us look into the another last parent function here, that is
Mm-hmm.
piecewise defined function. So
Mm-hmm.
basically what happened, there is no such specific example. It is the type of the function. You will get something like this: fx is equal to x square if, this is just one example, fx is greater than 1, x plus 1 if x is less than or equal to 1. This is just one example. So here you can see that
Mm-hmm.
for a particular values of x, you have to define one function, and for another
Mm-hmm.
values of x you have to define another function. Such type of
Yes.
function is called piecewise defined function. Now, what is its domain range? That depends on specifically the given question. So the question will determine, that question will help you in determining the domain and range and other properties of the entire function. So just
Yeah.
it is just one example.
Mm-hmm.
So now we can look into a little bit example of step function. Okay.
Yes.
So tell me this answer. If we have one step function
Mm-hmm.
like this, I'm representing it by single bracket.
Okay.
So tell me what is the value for f minus 1? What is the value
Uh,
for f2? What is the value for f3 over 2?
so this one would be 2, right? This one would be -1, and this would be less than or equal to, so it would be 1, correct?
No, wrong. Baba, I have given you question
Oh,
this one plus one.
you've given intercept, sorry.
Yes. So
So
whatever
would
you
you
got,
do
you have to just
so
add
you
it.
so my question is, first, would you do like -1? So like this one would turn out to be -1 if there's no intercept, right? Would you add the
Yes.
1 to the negative
Yes.
1?
Yes. Yes. Yes.
Oh, okay.
So how much you will get?
Like
0.
that? Yes, 0.
So okay. Write it properly. So -1 plus 1 is equal to 0. Perfect. What is
Yes.
f2? 3.
Hmm.
f3 by 2? 2. Very good.
Yes.
This is what it is. Okay. Uh, so this in this way we have completed all the parent functions.
Hmm.
Right. I will give you some questions that you can do as homework. Right.
Hmm.
And okay. So let us do some problems.
Hmm.
And in next class we will discuss the next chapter. Right.
Yes. Yes.